Hello, everyone. Welcome back. Today we are going to talk about trigonometric integrals. So you will learn many technique about the power of sines, cosines, tangent, and secant today. Okay. So integrating power of sines x or cosine x. Two strategies are used when evaluating integral of the form integral of sines to the power of mx dx or integral of cosines to the power of nx dx, where m and n are positive integers. Both strategies use trigonometric identity to recast the integral. So let's start. So, so you need to remember, on both ways, you have to know we will be using substitution. But when we use substitution, if you say u is, like for example, cosines x, then you need to know du will be what? Sine x times, and then du will be negative sine x dx, right? So I will need sine x dx, or if you said your u is sine x, your du will be what? Cosine x dx. So that is why whenever you are evaluating power of sines or cosines, we will be using identities to break it down. So once we find the derivative, we can direct substitute. Okay, so that's the point. So now look at our first example. What do we have? We are asked to integrate cosines to the power of 5x dx. So for me to integrate this one, my first step will be to remember that I know cosine square x is what? 1 minus sine square of x, right? But this is to the power of 5. So I have to rewrite my integral. I can set cosines of 5 to the power of x dx. It's same thing as what? The integral of cosines to the power of 4x times cosines x dx, right? I haven't, because if I multiply x to the power of 5, then I know I'm going to go step by step so you can see. I know cosines to the power of 4x is same thing as what? Cosine square x square times cosines of x dx, right? You can see I haven't changed anything yet. I'm still working on my previous one, so I'm just rewriting. So now my cos, because again, I know I have to get a sines here. So if I substitute, if I do my u substitution, I would have u is sines x, then du will be, this one will become du. That was the goal. Do you understand? So this will be what? The integral of cosine square is what? 1 minus sine square. So 1 minus sine square x to the square times cosine x dx. Right? So now I can use my substitution now. Do you get it? So now I can set, going to use this block right here. Let u be equal to sine x. Then du will be what? Cosine of x dx. So do you see? This is my du now, right? And this is my u. So I will get, if I do my u substitution, so now my integral will become what? 1 minus u square to the square times du. And then, I can expand this one. Once I expand this, I can expand 1 minus u squared to the square. Once we expand that, we will get what? Integral of 1 minus 2u squared plus u to the power of 4 du, which we know the antiderivative of that will be u minus 2 divided by 3u squared plus 1 divided by 5 u to the power of 5 plus c. And then what is our u sans x? So we substitute sans x at the end. So we'll have sans of x minus 2 divided by 3 sine square of x plus 1 divided by 5 sine to the power of 5x plus c. And that is my final answer. Right? That's my final answer. So the same thing we'll do with finding the integral of sine to the power of 4x dx. Okay? So in this case, you can see this power is even already. Right? This power is even already. So we have to think about maybe half angle or but so this power is even and it's hard to get your du when we just said u is equal to sine x. I need cosine, negative cosine x dx right here, right? That cannot happen. And I know some of you will think like, okay, why if I make it 1 minus cosine square x times 1 minus cosine square x? That also will not help. You can try it because, the best way to learn is try and see it does not work. So you will try a new thing. Does that make sense to you? That's how you learn math. Because even if I distribute this one, I will still have cosines to the power of 4x. So I have to, so this will be, so the best way is to use the reduced power trigonometric identities, which is same thing as half angle. Okay, the half angle said what we know, sine square of x is equal to 1 minus cosine of 2x divided by 2. And of course, cosine square of x is what? 1 plus cosine of 2x divided by 2. So it's called power reducing formula or also half angle. Okay, so that's what we have to use to get this one. So first thing, I would say what? My integral. Let me start this below. So first thing I will write, the integral of sine to the power of 4x dx can be rewrite as the integral of sine square x times sine square x, right? So I'm going to reduce the power. And then you can see sine square, which we know is half angle. So we'll have the integral of 1 minus cosine of 2x divided by 2, right? Times 1 minus cosine of 2x divided by 2 dx. Then next, what can we do is distribute this one. But before I distribute, you know, if you multiply these two, it will give you to the fourth. So I can take 1/4 out. So basically, what I have is 2 times 2 is 4. So I can take 1/4 is a constant, right? And it will left what? 1 minus cosine of 2x squared dx. Still, if I use a substitution here, I will have cosine of 2x and then du, which will be what? Negative 1/2 sine of 2x. So I still cannot do substitution. If you understand, I cannot still do a substitution right here. So that is why, okay, I will expand this one. If I expand 1 minus cosine of 2x squared, I will get what? 1 minus 2 cosine of 2x, right? And then plus cosine of 2x, cosine square of 2x dx. So which you can see, we can easily integrate 1. We can easily integrate cosine of 2x, but we have cosine square here. Again, I need to use the half angle, or also called as the power reducing formula of cosines, because you know right here we already said cosine square of x is what? 1 plus cosine of 2x divided by 2. So of course, if I make this one 2x instead of 2, so I can see cosine of 2x, cosine square of 2x will be 1 plus cosine of 4x, right? Because 2x times 2 will be 4x divided by 2. So that's what I will do right here next. Next, I'm about to change this one, because again, I know this will be 1 plus cosine of 4x divided by 2. So that is why my integral will become 1 over 4 integral of 1 minus 2 cosine of 2x plus 1/2 plus 1/2 cosine of 4x dx. Do you get it? So I just take 1/2, 1 over 4 cosine of 4x. So now, again, please, anytime you get confused, please pause the video and try to understand, okay? So I will have what? 1 divided by 4 times, what is the, I'm going to combine 1/2 and 1, which will be 3 divided by 2, right? Minus 2 cosine of 2x, right? And then plus 1/2 cosine of 4x dx. then we can easily integrate this one. That's using the basic integration formula. So I will have what? 1 over 4 times 3 divided by 2x, right? Minus sine of 2x minus 1 over 8 sorry, this will be plus, yes, plus 1 over 8 sine of 4x plus c. And that's it. Okay. So now, what about if you have the product of power of sines and or cosines? This is the technique you have to use. So please, let's read and follow this direction, okay? So while you are integrating product of power of sines x or cosines x, we now consider integral of the form, the integral of sines to the power of mx times cosines to the power of nx dx. Always follow this step. If m is an odd, so which means the power of sines is odd, positive integer, we split off a factor of sine x. So we make it sine x times sines to what? An even power. Does that make sense to you? And write the remaining even power of sines x in terms of cosine of x. This step prepare the integrand from for the substitution. U is equal to cosine x. And the resulting integral is readily evaluated. Okay. A similar strategy is used when n is an odd positive integer. So either m is odd or n is odd, you can use this strategy. But if both m and n are even, so which means they are both even integer, the half angle formula are used to transform the integrand into a polynomial in cosines of 2x, each of whose term can be integrated. So like just we did with one here, okay? Do you understand? So let's go and do these two examples. And you can see evaluate the following integral. We have the integral of sines to the power of 4x times cosines to the power of 2x dx. So in this case, both m and n are what? Even. So we have to use half angle, right? So again, just to refresh your memory, we know sines square of x is what? 1 minus cosines of 2x divided by 2, and cosine square of x is 1 plus cosines of 2x over 2. So we have to do that until we do not have any more power, okay? And sometimes you have to use your trigonometric identity if it helps. So then I will just say my integral Sorry, I was mute. So what I did is inside the parenthesis is science square x, so to the square, because you see I just substitute, and this is cosine square of x, right? Then you know we can do something right here. No. Oh, it's okay. I'm gonna go step by step so you can see what is happening. You know, this is 2 square, which is 4. 4 times 2 is 8. So I will have 1 over 8 outside the integral, and 1 minus cosine of 2x squared. We have done that before. You know, that will be 1 minus 2 cosine of 2x plus cosine square of 2x, right? And then times this 1 plus cosine of 2x dx. Then we will distribute this as well again. If I distribute one more time, 1 times 1 is 1, and then I'll combine like terms as well, okay? 1 times cosine of 2x is cosine of 2x, but negative cosine of 2x times 1 is negative 2 cosine of 2x. So if I combine those two, it will give me negative cosine of 2x, and negative 2 cosine of 2x times cosine of 2x will give me negative 2 cosine square of 2x. But this cosine square of 2x times 1, or you know what, let me just distribute everything and then we'll combine like terms. I don't want you to get confused. So let's go ahead and do that. I'm going to make it small so you can see. Plus cosine of 2x, right? And then we'll distribute negative 2 cosine of 2x minus 2 cosine square of 2x plus cosine square of 2x plus cosine cube of 2x and then dx. So if I combine like terms, I hope you understand now. We just distribute everything. I will get 1 over 8 integral of 1 minus cosine of 2x minus cosine square of 2x and then plus cosine cube of 2x dx. Okay, now you can see, you know, I can integrate each of this one independently, right? I don't know if you understand. I can integrate each of this one independently. Like I can say this is same thing as 1 over 8, because now you can see these two, the integral of these two can be found easily, right? So I will write 1 minus cosine of, let me use a bracket here. So 1 minus cosine of 2x dx, because that can be found easily, minus the integral of cosine square x dx plus the integral of cosine cube 2x dx, right? So these two can be found easily, and you can see we can use half angle formula on this one. So Again, I will have 1 divided by 8. I can go ahead and find this antiderivative, which is x, right? And the antiderivative of negative cosine of 2x will be negative 1/2 sine of 2x small parenthesis minus, we can use half angle formula for this one right here. Don't forget we have 2x here, right? So using the half angle formula, this one will become the integral of 1 plus cosine of 4x divided by 2 dx, right? And for this one, this is odd, right? Third one is odd. So we can use substitution in here, because I will rewrite this one as the integral of cosine square of 2x times cosine of 2x dx. And you know we can use half angle here. And we already have that cosine square of 2x. Half angle is what? 1 plus cosine 4x divided by 2. So you can see this is long, but as long as your algebra is good, just follow your algebra. So we will have 1/8 bracket. We have already solved x minus 1/2 sine of 2x. And same thing here, we can for solve this one. This will be minus 1/2 x, and the antiderivative of cosine is sine, so minus 4 times 2 is 8, 1/8 sine of 4x, and then plus this now will become the integral of 1/2 plus cosine of 4x and 1/2 cosine of 4x, which means I can take 1/2 out, right? So I will have no fraction inside. So let me take this 1/2 off. So 1 plus cosine of 4x times or you know what? No. I'm not gonna do this one right here. Sorry. My bad. That will not work if I use half angle, because this one will be 4x. That's why sometimes you need to, we said we'd use substitution. So this is 1 minus sine square of 2x, right? Cosine square of 2x is 1 minus sine square of 2x. So times this cosine of 2x dx. So I'm going to use the u substitution for this part. For this part, u substitution. Okay. Once you know, as is long, that make it even more fun. So of course, this one, if I use u substitution, u will be what? Sine of 2x, right? So we'll say the u is sinus 2x. So which means du will be 1/2. Sorry, du will be 2 cosine of 2x dx. There is no 2 here, so we have to use 1/2, right? So basically, our integral will be 1/8. We can combine these two. X minus 1/2 x will be 1/2 x, right? Minus 1/2 sine of 2x minus 1/8 sine of 4x. Now plus, using the u substitution here, this integral will become 1 minus u squared. Take the 1/2 out, du, right? Which will give us 1/8 1/2 x minus 1/2 sine of 2x minus 1/8 sine of 4x. The antiderivative of this will be plus 1/2 times u minus 1/3 u to the power of 3 plus c, right? Or what is our u? Sine of 2x. So I'm going to substitute my u. So by substituting my u, I will get 1/8 1/2 x minus 1/2 sine of 2x minus 1/8 sine of 4x plus 1/2 sine of 2x minus 1/6 sine cube of 2x plus c, right? And then we will try to combine like terms. So now the rest is to combine like terms. So we still have this 1/2 x, negative 1/2 sine of 2x plus 1/2 sine of 2x will cancel out, right? These two will cancel out. So it will left minus 1/8 sine of 4x minus 1/6 sine of cube of 2x, then plus c, which now we can see If I just you, it's a choice. You can distribute 1 over 8 or you can leave it like this. If you decide to distribute your 1 over 8, 1 over 8 times 1/2 will give me what? Let me bring it down a little bit so I can. So my final answer will be 1 divided by 16x minus 1 over 8 times 1 over 8 is 1 divided by 64. Sines of 4x. 1 over 8 times negative 1 over 6 will be 1 over 48 sines to the power of 2x, then plus c, and then that's it. Again, I know this is a little bit long, but you know, it's always following your algebra knowledge, okay? Then next, we have to find b, which is sines cube times cosines of -2 or cosines power to the power of -2 x dx. So in this case, you can see sines to the power of 3 is what? Odd. So since that is odd, we will not be using half angle. So we have sines to the power of 3 x times cosines to the power of -2x dx. We'll say the same thing as sines to the power of square x times cosines to the power of -2x times sines x dx, because sines x times sines square x will give me sines to the power of 3x. So I want you to get used to this, because you can see I'm doing this one because this one will become my d, okay? That's the substitution. That's the rule of substitution. But sines square x is what? This will be give me sine square of x is 1 minus cosine square of x times cosines to the power of -2x times sines x dx. You know, you can see we have, I will just say let u be equal to cosines of x, right? Then du will just be what? Negative sines x dx. So if I substitute my u and du, this is what my integral will become. This is what the integral will become. It will become the integral of 1 minus u square times u to the power of -2 du. That's it. So now what can we do? We can just distribute this u to the power of -2 inside, right? Oh, this is negative, so I will take this negative out. Okay? Because this will become negative du, will be sines x dx. So I will just take the negative out, okay? So we will distribute u to the power of -2 inside. So that will give me u to the power of -2 minus 1 du. Which if you find the antiderivative, it will give you what? We already have this negative, u to the power of -2. If you add 1, it will become negative u to the power of -1 minus u plus c. Does that make sense to everyone? Which is exactly the same thing as if I 1 divided by u, because if you distribute this negative, this one will become positive. U to the power of negative 1 is 1 divided by u plus u plus c. Or what is our u? Our u is what? Cosine x, right? So my final answer will be 1 divided by cosine of x plus cosine of x plus c. And if you don't like, 1 divided by cosine of x is what? Second x. So you can change this one to second x plus cosine x plus c. Hope you understand this. Now, again, this is the strategy you need to remember, okay? If m is odd and m is odd and positive n can be any real number, split off sin x. Rewrite the resulting even power of sin x in terms of cosine of x, and then use u is equal to cosine x. And if n is odd and positive, m is a real number, split cosine x, and then u will be what? Sin x. If m and n both are even, use half angle formula, okay? So same thing for assume n is, this is the reduction formulas, okay? So you can use any of these 4 formulas if you need to reduce the power of the given integral, okay? Like the integral of sine to the power of nx, and to the power of n x dx is negative sine to the power of n minus 1 x times cosine x divided by n plus n minus 1 divided by n integral of sine to the power of n minus 2x dx, and so on. So let's do this example, integral of tangent to the power of x dx, okay? So based on the given information about the reduction formulas, you can see tangent to the power of 4x dx will be equal to, my n is 4, right? So it will be tangent 4 minus 1, which is 3, right? 4 minus 1 is 3, divided by 3 minus the integral of tangent 4 minus 2 is 2 x dx. So you see we still have tangent square here. So I will again use the same formula again. So of course we know we already have 1/3 tangent to the power of 3x minus. Now if I'm going to use a parenthesis, so I will distribute my negative if I need it. Tangent square, my n is 2, so it will be 2 minus 1, which is 1. So it will be tangent x divided by 1, right? Minus the integral of tangent of n minus 2. My n is 2, 2 minus 2 is 0. So tangent to the power of 0 x dx. And you know tangent, anything to the power of 0 is what? 1, right? This is 1, right? What is the antiderivative of 1? X. Good job. So my final answer will be 1/3 tangent to the power of 3x minus tangent x minus x. Minus and minus will be positive, so plus x plus c. This will be my final answer. Okay. There is another way to do this one as well. Okay. We could use, I'm not going to do that because the video is, I don't want to make it a long video, but this tangent to the power of 4x, we could make it what? That's even, which we will see right now. We could do tangent square times tangent square, right? And tangent square is what? Secant square minus 1, and then we could use our substitution to solve. Okay, like this one. You see, this is now the product of tangent to the power of m times secant to the power of n. Same thing as we did with sine and cosine. So if n is even, split secant square, rewrite the remaining even power of secant x in terms of tangent x, and use u is equal to tangent. If m is odd and positive, split off secant tangent, rewrite the remaining even power of tangent x in terms of secant x, and u is equal to secant s. If m is even and positive, n is odd and positive, rewrite the even power of tangent x in terms of sine x to produce a polynomial in secant x. Apply. So read this one before you start anything. So let me try to do these two examples quick, and that will resume on this section. Okay, so you can see for the first one we have tangent to the power of 3x times secant to the power of 4x, right? So which means m is even and n is odd, right? So we will do what? We'll say this is tangent to the power of 3x, to the power of 3x times secant square x times secant square x dx. And what is our secant square x? One of the secant square x will be rewrite in terms of tangent so times tangent square x plus 1, then times secant square x dx. So now I can use my substitution. If I said let u be equal to tangent x, again, do not forget, this is your identities. Secant square is same thing as tangent square of x plus 1. That's what I did. I did that substitution. Then my du will be what? Secant square x dx. So that's why I did not expand this one, because since the beginning I know this one will be my du. You have to anticipate your next move. So most of the time when you are doing math. So doing this substitution, I will get u to the power of 3 times u squared plus 1 du, right? Which if I distribute, I will get the integral of u to the power of 5, u to the power of 5 plus u to the power of 3 du. And the entire derivative of this one would be 1 over 6 u to the power of 6 plus 1 over 4 u to the power of 4 plus c. And what is our u? Tangent. So my final answer will be 1 over 6 tangent to the power of 6x plus 1 over 4 tangent to the power of 4x plus c. And that's it. Okay. And then the next one is tangent square times secant of x dx. So in this case, if I have to integrate this one, tangent square. So you can see tangent, the power of tangent m is even in this case. So I will just rewrite my m in terms of second, okay? So which will be the integral of secant square x minus 1 times secant x dx. And then if I distribute this one, it will give me secant to the power of 3x minus secant x dx, right? So we already know how to find the antiderivative of secant square, but what about secant cube? So we have to use the reduced formula again, right? So I can separate this one to make it secant cube x dx minus the integral of secant x dx. So if I use the reduce for secant, you see, the reduce power for secant, which would be secant to the power of n minus 2 times cotangent x divided by n minus 1 times n minus 2 divided by n minus 1 integral of secant of n minus 2. So that's exactly what I have to do right here. So my n is 3, right? My n is 3, so sorry for this one, I will have secant n minus 2, which will be what? 1, right? 3 minus 2 is 1, so secant x tangent of x divided by n minus 1, so divide by 2 plus n minus 2, so 3 minus 2 is 1, divided by 3 minus 1, which is 1 half, the integral of secant of n minus 2, 3 minus 2 is 1, secant x dx, then minus, what's the secant x, well, secant x dx, and the integral of secant x dx, we already know that, but first, we have 1 half secant x dx minus secant minus the integral of secant x dx. So we can combine those two integral, right? Instead of, integrate both and combine like terms, we can just combine these two. So if I combine these two, that will give me, should I put 1 half in front? That's looking beautiful. 1 half secant x dx tangent of x, then minus 1 half the integral of secant x dx. Or we know the integral for secant x dx, we did this one long time ago, the beginning of the integral of trigonometric. We know that is, we have this negative 1 half ln of absolute value of secant of x plus tangent x, then plus my c. And that's it. Okay, this is the end of this section. You know, your algebra needs to be good to understand this one. So please pay attention, okay? We'll see you in the next section.